Grid UK, as well as UK networks. GE commissioned a sequel of projects with him to analyze and solve wind farm high voltage direct current grid interaction problems in 2013 to 2019. Professor Paul was the chief technical consultant for a panel of experts appointed by the United Nations Framework Convention on Climate Change Clean Development Mechanism. He has offered trainings in Chile, Qatar, United Arab Emirates, Malaysia, and India in power system protections, stability, and control topics. He has developed and validated a prize-winning 68-bus power system model, which now forms a part of IEEE benchmark systems as a standard for researchers to validate their innovations in stability analysis and control design. He was the editor-in-chief of IEEE Transactions on Sustainable Energy since 2012 to 2017, and editor-in-chief of IET Generation, Transmission and Distribution from 2005 to 2012. He is Vice President of PES Publications since 2019. In 2016, his research team won the President's Outstanding Research Team Award at Imperial College London. He is Fellow of IEEE for his contribution to power system stability and control. He was an IEEE Distinguished Lecturer in Power Distribution Systems, Estimation and Control. He has published about 100 papers in IEEE Transactions and IET journals and authored 4 books in power systems modeling, dynamics, estimations, and control. 2 of his papers in power system stability and control topics have received annual Best Journal Paper Award. He was Otto-Monstedt Professor at Denmark Technical University and Mercator Professor sponsored by German Research Foundation at University of Duisburg-Essen in 2011. He worked as faculty at IIT Kanpur, India. He holds a visiting professorship at Tsinghua University in China. In today's talk, he is going to be taking us through dynamic estimation and control of power systems. I will just give a bit of an abridgment on what he's going to share with us. Electrical generation, transmission, and distribution systems all over the world have entered a period of significant renewal and technological change and upgrade.
I can cover that. I can cover that briefing.
Okay, so thank you so much, Professor Paul. Welcome to the platform.
Thank you. First of all, I'm very sorry that I'm very late. There is no reason actually except, I just forgot about it, and also I am not feeling well since early in the morning. So I was, sleeping, and I really needed to sleep. Then only when I got the call from Ravindranath, so I realized that yes, I have this. So let's start this. I will do this estimation part, given we lost, the time, and then I'll be very brief on the control aspect. So there is a transition from low carbon generation towards low carbon generation. That means we got new technology and we need to have new methodologies of control operations. And these things, then are in a situation that whether we know much of their characteristics or not, so that we find the estimation very important in that situation. And time criticality is also important because we now have the event that would be developing in this new technology generation heavy systems, which will evolve very fast. So the time criticality is important. The dynamic state estimation is also important from control point of view, particularly whether it is transmission or distribution. We need to have the fast voltage as well as power flow control mechanisms. We have in transmission systems, that is STATCOM and FACTS. Now in distribution also they are coming up, for reconfiguring the network, etc., etc. So this is how it is. Whenever there is a drop in the generations, the frequency starts falling, which is constrained by the inertia of the system, that is called frequency containment reserve. And then after that, the primary first primary response kicks in, mainly the droop control, and following that, around 30 seconds, as it is in this diagram, we will have the secondary response, that is low frequency controls and so on. The delay for estimating the states that way is very important. It has to be very fast because you see the rate of fall is being regulated by inertia. So in that case, inertia is dropping in the systems. So in that case, the estimation speed and accuracy is also required to be very fast. Challenges in centralized dynamic state estimation, because you need to get all the information to a central location where you are doing all your computations, that is communication network, and in present day power system, they are not fast enough. Plus there are the technical challenges of packet dropouts, or the information dropout, information delays, as well as the security of the transmission of the network over the communication network. So cyber security as well as the delays are the bottleneck in centralized state estimation. In this alternative, approach would be that every individual generator can be estimated locally from the local measurements. Usually, the generators have the dynamic characterizations by differential algebraic equations. Like for a synchronous generator, you take the synchronous machine dynamics by differential equations, and stator current transient as 50 Hz frequency you neglect for differential algebraic pattern. But it is, in decentralized or in any kind of state estimation, we could have all of them differential equations. That's not an issue. But you could express them like this: x dot equal to gx y u. That means the input, state, and algebraic variable. And typically also you could have output. So what are the inputs? Typically for synchronous generators, we are doing the voltage control and power control. So set point of the power order can be your input, as well as set point for the voltage reference can be your input. Apart from that, we introduce two quantities we call actually pseudo input, V and theta. So what are these V and theta? Typically, generator, whether it is synchronous or asynchronous, would be connected to the network through voltage and angle, so V and theta. And then it would be injecting current to the network through current and its phase angle. So if we treat these two interface quantities as input and output, then that particular unit, the generator, is decoupled from the rest of the systems through these variables. So this is how we can formulate through these pseudo inputs. And then we of course have to take care of the noise parameters from this. So anything that you measure that will have some noise. So the actual variables would be that minus the noise. The state estimation through this decentralized dynamic state estimation is still effective because the generator is connected to the network through support voltage V and its angle, and also it is providing current I and phi. Now these are all algebraic variables, so they are electromagnetic time scale. That is, they propagate fast. So anything that happens in the network that at electromagnetic time scale, they also propagate. So that way, any impact of the rest of the network would be easily captured by the variation of V and theta, which is that way instantaneous compared to the other dynamics, and so with the current and phase. So mathematically, the generator is decoupled from the systems, whereas electromagnetically it is coupled. So we do not lose any kind of interactive behavior of one part of the systems with the rest. Then we put this into filtering approach, that is kind of uncertain Kalman filtering. The probability distribution of the estimated state by generating sigma points, and then it also gives you opportunity to avoid the costly linearizations of the Jacobians. Then we could assume some kind of characteristics of the noise for these states. So this is our this is how the setup. So get all the sigma point generated from the previous estimate x hat here, and add this state covariance matrix square root, which is the Cholesky's factorizations. Do it for plus and minus so that you got 2n sigma point. This xi is the state vector for the ith unit, px is the covariance. Then what you do, you get actually prediction, which is essentially utilizing all sigma point generations to get this predicted value and then take the mean of it. So that's the predicted mean value. And also you could have this covariance of this the predicted value. We add a process noise which is in our head. I mean, we could define a process noise by standard deviations, which could be set from the standard like IEEE C37 and so on. Measurement prediction, similarly, this is measurement expression. We could have mean of that and then measurement covariance, and then we have a cross covariance with the measurement noise. The cross covariance will have this Vx I hat. Then once you get all these three covariance matrices as well as state and measurement covariance, you could get the Kalman gain, which is this, and then with that gain update the predicted state to estimated state by this, and also then update all your covariance matrix with this Kalman again. Noise, as I said, that it has to have this Gaussian with the total vector error. You could take a percentage as it is stipulated in or specified in 37.118. Now the standard is also changed to 218. So process noise, it's a known variance we could add, and then that could also be Gaussian in nature. Then we could go. This is the 68 bus benchmark system that we introduced to the IEEE task force a couple of years back, on which we'll be working. There are 5 or 6 areas, 5 areas mainly, and power flows from one area to another area will have some kind of oscillations which you would like to damp out through control. So this is the estimations. You have a measurement, and then that we generate the measurement through simulation, and then do the estimate, which is the red. And you see that estimate as well as the simulation results are very much matching. That means that gives you a confidence that your estimation algorithms, that UKF is working. We also have the accuracy that display that to you, that is of the order of 10 to the power of -4. So this is how the accuracy behaves. Feasibility in terms of the computational speed, this is again decentralized algorithm. So it is irrespective of the size of the network, we are doing for every generators decentrally. So 1/3 of a second. Whereas if we do centrally, we got to do all these things together in a centralized equations. So it is going up. Typically, for a 5-fold increase in the system size, you see that this is going to about 100 times. So that's how it is also very fast compared to the centralized approach. There are some challenges with the PMU-based this DSC. It relies on the GPS synchronizations. GPS susceptible to atmospheric effects, clock errors, and multipath effects. The issue of cybersecurity, poor accuracy for standard PMU noise are there. And then there are many PMUs has got vendor-dependent accuracy, latency, and sampling rate. So finding an alternative to PMU base, what we could do, that we saw that V and theta, that theta was our pseudo input. So what we could do, so that theta is always with respect to some synchronous common reference frame angle, right? Because in power flow studies, we always have a slack bus. We treat that angle as the reference, one angle as 0, and then all the rest of the angles we express with respect to that. So in this case also, when you are doing V and theta, the generator, the voltage magnitude and this angle, pseudo input, so that is now then relying on a common reference angle. What we could do, generator will have two quantities. Typically for a synchronous generators, we got load angle delta and also this voltage magnitude plus voltage angle, terminal voltage, bus voltage angle that comes from the even power flow also. So this delta and theta, both of them are with respect to that synchronous reference frame, the angle. So what we could do, rather than relying on the synchronous reference frame angle, which has to be transmitted over transmission network every iterations, what we could do, then we take the difference of this delta and this theta. That means that way this difference will be then independent of that the synchronous with the reference angle, common reference frame angle. So that way, then this alpha becomes delta minus theta, and then if you take the square, the derivative of this alpha, this becomes d delta minus d theta dt. That means omega, the generator speed minus the local frequency. Now you see that everything is now localized. You do not need to do anything, yet you are very much time synchronized. So this is how we do it. And before doing that, we also can improve this UKF performance, because UKF, as I told you, that it works on that state covariance and output covariance and cross covariance matrix statistical property. So this those matrices, they will have the sigmas, right? And those sigmas at every iterations can be changed. That is how the UKF algorithms works. Now, if we do the signal processing this way, that we get the signal from the network, and then we do the digitizations, and then we pass it through a pre-filter, we call interpolating discrete Fourier transformations. That would make actually this frequency, that would make the condition of the signal even better. Like every time you are getting the estimated frequency, estimated angle, and also the estimated magnitude of that voltage, along with comes actually this the standard deviation, the quantities. So that is how it can be done. And then this is the expression for them. Then what you could do, you have a robust estimate of these states, and on that good control algorithms can be very effective. So this is how the dynamic state estimation, the effectiveness that happens. See that simulated values red, and DSC with PMU 1% total vector error with measurements, but we don't have IDFT, that is a lot of jitters, and robust DSC without PMU and 3% error in measurements. If we do, now we don't have PMU measurement, we do, then we have this. So this is that way the effect of the DSC in error measurements are also better. Well, this is again what you see, various states and their associated error when you do with these RMSE quantities, and then this is when you do the robust, estimated error. Fine. Benefits robust DSC is that it is accurate. So I mean, we don't need to say anything more than that. Low estimation time delay. This IDFT is pretty fast. So this is how we go. Control, I need to be quite quick on this. Basic power system oscillator stability control, we need to see that all our closed loop poles are on the left half of the S-plane for stability. Now, if we can guarantee them within these conic sectors, then it is even having a minimum damping. Now, when you try to do this is in S-plane and continuous time domain, that is fine, but we are designing everything in digital time domain. So what actually becomes S-pole in the continuous time domain, it becomes a Z-plane, it becomes a circle in this, and as long as all the poles are inside the circle, that is stable. So now this conic sector in that case, okay, 1 second, right. So now, so then what we do? Then we do this, we got the decentralizations and extended LQR methodology in place, like x dot equal to x plus bu. Then also we bring in this pseudo input that we have used for decentralization. The total quadratic cost after incorporating the cost associated with pseudo input is this. So this is the additional thing, and this additional thing we derived by this expression, which are coming from this state and matrix as well as input matrix plus the solution of the algebraic Riccati equations. So this is the additional term GI that is there. So that then how you include the damping criteria, damping control using this extended LQR. So the loops, so we need to see that conic section that corresponds to the specified damping in S-plane maps to a logarithmic spiral in Z-plane. See, the whole, the left half of the S-plane is a circle in the Z-plane. Now, a cone on that is a spiral, right? And if you take actually then again imaginary axis as your cone, that is zero damping, then that spiral again become that circle. So this spiral, elliptical spiral, can be then approximated by disk with a radius of r and then beta 0. So what is radii and beta? This actually would decide that at what frequency and what minimum damping you want to do. So accordingly, the extended LQR formulations will have this sort of transformations of variables from a, b, and b prime to a minus beta I, r, beta y, r, and beta prime by r. This is because we are now restricting ourselves to a conic sector, which has been a spiral in z plane, but then we have approximated by the disk of radius r at a beta. So this is how it is. So at the tangent point, when this is your disk and this is your spiral, so we are approximating this whole spiral by this disk. So at this point it just touches, so that is the point which is the minimum damping and the frequency which you could set from the open loop. So that's the complete methodology, and then you come with this whole this formulation. This is your generators, this is you are getting this measurements v theta I phi, so pseudo inputs, do the dynamic state estimations, and then what you also do, put the IDFT to a robust estimated states and utilize this input for extended LQR, and then generate your control. That goes to the automatic voltage regulators for synchronous machines, and then it control this. So for each of them, we have now decentralized things. All we need is actually GPS satellite, which is mainly for time, synchronization, just time stamping, so that it is, so it does not need any kind of common reference, an angle. That's the network I mentioned. So we put actually a thyristor control series capacitor between two areas, and then we see what happens. This is with the extended LQR control, and this is with the PSS control. So this is better. There also we show you the closed loop damping and the open loop damping for different methodologies. Extended LQR damping are better. Now, at what cost? The cost also for extended LQRs are less. This is the total cost, and inside is the state control cost and the control cost and the state deviation cost. So if you see there, for different operating scenario for that network model, 700 megawatt and 100 megawatt flow between these two, that's the range. We see that this is better.
Sir,
So yes,
sorry to interrupt you. Sir, please make a single screen, because it is going on YouTube live also. So please make it a single.
okay.
Yeah, thank you.
So
Thank you, sir.
sorry. Now this is, sorry, I forgot about that. So limitations that this it is only applicable for small distance, small disturbance. So what we could do then, we could design again normal form based nonlinear control, which also can again work out to be effective. But then the cost of the normal form based control, these are all the details, are very expensive. So there you see that the nonlinear control, this is the black. An open loop is this oscillatory, and then PSS. So this is extended LQR is blue. So this requires huge amount of effort, control effort, which we should also be careful. So whenever there is a fault in the network, that time the tangent stability is the considerations. We are not doing anything with the the oscillator instability control. For about the 4 to 5 cycles Baker opening time, we see that happens. Let the tangent stability control mechanism takes care of it. That is overfluxing, or the fast valving, those type of actions where the excitation systems voltage is suddenly increased that way. And after the fault is cleared, still there is a huge amount of nonlinearity, and from that point onwards, we could bring this nonlinear control. And after some time, when this the oscillation has settled quickly, then we could do this. The reason is, if you put actually nonlinear control, it requires a lot of actually control effort. Means the voltage reference point of the AVR would be set to be high, and then that actually lead to the slow variation of overfluxing of the generator current transformer GT, because the frequency is very low. So slow variation of the terminal voltage means the generator transformers are all designed to operate on the knee point, and then if we have a very slow frequency variation, because of that the iron loss of the generators would be so high that the generator transformers would be also heating up. So that's the idea of restricting the nonlinear control to a very small amount of time, and these are all the the plus and minuses of that type of control. So best thing is combine them together. For some time, keep the nonlinear control, and then for majority of the time, bring the small signal stability control back. So this is how it is. We did, and there are a lot of work that honestly in half an hour I could not cover. That is available in this book, Dynamic Estimation and Control of Power Systems. That's the work of Dr. Singh, who is an assistant professor in University of Southampton, and all of them are available in this, book. We also have, many other activities going on in our group. So control, modeling, monitoring, estimations, distribution systems as well as transmission systems. We have, these are all the current researchers. And Abhirav is still connected to me as a visiting researchers in the group. So that's how is my group at Imperial College, functions. We have been privileged to have funding from our government, UK PSRC, as well as European Research Councils, Marie Curie programs, and also in the past, this wind farm modeling from GE Alstom. And currently, we are also working on impedance modeling from National Grid projects and many distribution companies, couple of distribution companies to be precise, UK Power Network and Scottish and Southern Energy on distribution system state estimations and so on. So that's all about this. I'm so sorry, Ravindra. It is essentially I knew that last night that I have this talk, but then I woke up very early in the morning, and then I don't know why it happened, and then suddenly I started feeling very unwell. So I slept until I got your phone call. So again I woke up. So sorry, gentlemen, for being in a rush and covering loads of things quickly, which may not be
It's okay, sir.
okay. Okay. So if you have any questions,
Any question, sir, kindly, audience, any question, kindly
write
write.
to me because I know that you have another after 10, 11. So I'm already 5 minutes into the next session, isn't it? So
No, sir, no, sir, no, sir. I have a time, sir. Sir, if any question, kindly write in chat box to Pal, sir, Professor Pal, directly, so that he can read the question. Sir, in right side corner, there is option chat.
yeah, I know this. There is an option chat. Let me go back to this.
Okay. So, audience, any question, then write to sir, or I share sir's mail ID if any
Stop video. Chat.
question, and then.
Yeah, there is no question in the chat box. So for the timing, we are okay. Okay.
Yes, sir. Actually,
Yeah, that is what is UK the best
chat box.
Yeah, this EKF is the best so far because EKF need these algebra, these Jacobian estimations, and you could also think about any other estimators like particle filters and so on. But the advantage of the UKF is that you could do this without numerical, linearizations, algebraizations. I mean, sorry, Jacobian. For dynamic estimation, yes, it is. I mean, for static estimations, we also do this weighted least squares and so on. But for dynamic state estimation, this is the best. Right? So this is the only question. How many people attended in this session? Hello?
Sir, this is actually, sir, this is this portal only for authors, and we go for the live streaming of YouTube. So your talk in YouTube also.
No,
So,
YouTube is fine. But as of now, in this live keynote, how many people attended this session?
sir, total number of participant. Sir, over
Okay,
for uh,
21.
sir, can be limit cycle of behavior law. There is a question, sir.
Okay, just a second. Sir, can we use limit cycle behavior of linear control? Limit cycle behavior of nonlinear control. What do you mean by that? The limit cycle, uh, I don't understand that question. Well, limit cycle, in a nonlinear, the dynamics, you see some limit cycle behavior, and that uh, happens. But then how you can use that for nonlinear control, I do not know. We need to have a lot of control energy. So in that case, we need to have, this is how it becomes very fast damped. Okay, limit cycle is the behavior of the system dynamics. It is not actually the, manifestation of the control itself. So let's do not mix actually two things. Right. If we do not have any other questions, so Ravindra, can we finish this?
Yes, sir. Yes, sir. Sir, I will share your email ID to all the authors. So if they have any questions, sir, kindly write. They are right to you. They will write to you. Angu, sir, please give the vote of thanks.
Okay. Stop.
A pleasant day to you, ladies and gentlemen. Today we have another outstanding keynote speaker for you, and it's actually quite an honor for me to introduce him. He's going to speak about the fourth industrial revolution and sustainable development, the role of technology and innovation. Professor Paul M. Cunningham is founder and executive director, IST Africa Institute, a not-for-profit research and policy organization. Established in 2002 and supported by the European Commission and African Union Commission, IST Africa is a strategic partnership which currently involves ministries and national councils responsible for innovation, science and technology, and sustainable development related adoption, implementation policy and research in 18 African member states. Open to participation by developing countries and in particular ACP group countries, IST Africa Institute is a member of the UN Sustainable Development Solutions Network and was recognized by the IITU as a WSIS Prizes 2018 champion for international and regional cooperation. The IST Africa Institute is focused on A, promotion and support of international cooperation related to sustainable development and innovation, science and technology related policy, research, education, and entrepreneurship in developing countries, and in particular ACP group countries. B, instigation, collaboration in and contributing to the core design and execution of sustainable development, research, innovation, international development, pilot, implementation, and entrepreneurship-oriented projects, and in particular, leveraging ICT and other technologies. And C, contributing to sustainable development, ICT 4D, and innovation, science and technology-related policy at national, regional, and international levels, with a particular emphasis on alignment of research and innovation with achieving sustainable socio-economic development. IST Africa publishes comprehensive reference reports on ICT initiatives, research capacity, and innovation spaces to support policy development. Helped African universities secure more than £200 million research and innovation funding in the last 10 years, provided evidence to secure £36 million in dedicated funding for European Commission Horizon 2020 research and innovation framework program calls addressing African societal challenges, and has achieved a significant increase in research publications from Africa and about Africa. Professor Paul, he has extensive experience contributing to policy formulation, requirements analysis, baseline studies, monitoring and evaluation, data analysis, and developing use cases and scenarios. He has over 20 years experience leading teams providing technological, strategic, research and policy expertise to national and international governmental organizations, as well as research and innovation programs, including assessment, monitoring and evaluation, and reviewing. Professor Paul has extensive international policy, research and innovation, and sustainable development related networks across Africa, Europe and North America, and enormous experience working as a technology, policy and innovation expert, and organizing ministerial level technology research and innovation conferences. Affiliated with IUM and Wrexham Glendower University, Professor Paul has an interdisciplinary background, Trinity College Dublin, Kodali Institute of Leeds, Ferenc Academy of Music, UC Smithfield Graduate Business School, Department of Computer and System Sciences, Stockholm University, and recognized by Enterprise Ireland as an Irish champion of EU research. A senior IEEE member, Professor Paul is Director-elect, IEEE Division 6, past President and VP conferences, IEEE Society on Social Implications of Technology, past Chair, IEEE Humanitarian Activities Committee, IEEE SSIT Distinguished Lecturer, and IEEE Vote Program Graduate and Mentor. Just as technological innovation is critical to driving socio-economic growth, it can also play a critical role in supporting successful implementation on the UN Sustainable Development Goals. This keynote will This keynote will discuss how to maximize the potential benefits of leveraging the potential offered by the fourth industrial revolution, with a particular focus on technology, innovation, and standards, while taking account of social implications of technology adoption, ethical considerations, including informed consent and potential impact on local socio-cultural norms. Once again, ladies and gentlemen, help me welcome Professor Paul M. Cunningham to the platform.
Thank you very much, Cadell, for that very kind introduction. Can you hear me okay?
Yes, I can hear you properly.
Perfect. Okay. So this morning I'm speaking in a personal capacity based on the experience that Cadell has kindly outlined. I hope that you will find it useful in the context of the overall objectives of the conference, and I look forward to discussing some of the ideas with you if there's time at the end of this session, and also hopefully afterwards. So, you've already got a background on IST Africa, so I'm not going to spend any time on that now. What I'd like to do to start with is to talk through the precursors to the fourth industrial revolution. So even though this slide looks Eurocentric, the simple reality is the industrial revolutions affected countries all over the world, particularly those who, like Ireland and like India, have had empire interaction over the past hundreds of years. So in the case of the first industrial revolution, energy, in this case hydroelectric and steam, and engineering innovation were the enabling technologies for mechanized production. So this mechanical engineering was very much focused around the locomotive and around textile production. So the spinning jenny that's very famous and the power loom. There was significantly increased importance of raw material consumption, iron and coal, and the production of textiles. And this is where the term cottage industries came from. This was precursors to factories where you had thousands of small enterprises. In a sense, the precursors to the small and medium-sized enterprises that many of us are familiar with today. And that industrialization led to a significant demand for what we would regard as unskilled labor. And one of the social consequences that's important to keep in the back of your mind is that this industrial revolution led to a significant growth in population. So there was increased demand on food production at the very same time as dependence on the agrarian or agricultural economy for employment was reducing. You can also see that the migration of the effect of industrial revolution started with an empire, in this case, Great Britain, and gradually expanded. And I'm going to talk through the rationale for that as we go through the rest of this presentation. The second industrial revolution, energy also has a critical
Hello, Valentina.
Hello, Bob. I'm here. Nice
How are you?
how to see you.
Good to see you. Would have been better in person, but
You are in UK, in Romania, and we are meeting in India.
very strange
Hello,
times.
sir. Our Vice Chancellor ma'am is also there, sir. Sir, ma'am.
Yes.
Ma'am.
Yes, Rabindra.
Preeti ma'am.
Yes.
Ma'am, our
Hello.
ma'am, Robert sir is there, sir. Robert sir is behind the KIF International.
Yes, I know Robert. I have interacted with him long back. I hope he remembers me. So, hi Valentina, how's life? Long time.
Yes, long time. Nagpur.
Yes,
Not possible to see you this year in Delhi. I was very, very busy. Maybe next year.
no problem. Always will be great to meet.
Congratulations for your 1,000 citations.
So, how's the
Madam,
Yes.
we have IEEE IAS president elect.
Okay.
Sir.
Good morning, or good evening, or good afternoon. Yeah, this is Wijan.
Good afternoon.
Hi, Vijan.
Hi. Well, you are in Australia. I'm in US, and yeah, we meet in the air. Yeah.
It's better than our earlier program. It's 10:30
It's,
here.
it's early for me, but well, it's okay. You know, 6:30 is not unusual.
Good evening, everybody. This is Professor Play.
Hi, Vincent. Hi, Vincent. How are you? Long time.
Hi. Yes.
Hello, Win.
How are you doing?
You will win this year.
This is going to be fun.
Pallavi, can we start?
Yes, sir. Very good afternoon to professors, guest speakers, and friends. Welcome to the closing ceremony of IEEE Conference GUCON-2020. It has been intense for 2 days, having various productive, wonderful, and technical programs. And today we are here to conclude our event. We have achieved a lot, and I'm very glad that there are still so many people stayed behind to attend the closing ceremony. Now I would invite Sri Dhruv Galgotia, CEO of Galgotia's University, to deliver his opening remarks for this session.
Pallavi sir, ma'am, CEO sir is in travel. Okay, so please go ahead with ma'am. Pallavi.
Okay, sir. So the Vice Chancellor of Galgotia's University, Professor Preeti Vijay, I address you to come and give your remarks for this session.
Thank you, Pallavi. So, Dr. Ravindra, Dr. Tripathi is going to join us.
Sir, Tripathi is a connection problem, sir. Sir, Robert sir is there. Robert is a chief guest today.
Yes. Yes. So, good evening, everyone. So, as per Indian Standard Time, I'm just wishing everyone to be good evening. So, good evening, everyone. So, chief guest of this valedictory function of GUCON 2020, Professor Robert Howlett, KES International Research University of Chester Business Incubation Center, UK. The guest of honor, Professor Vijen Lee. Guest of honor, Professor John Matthew. Guest of honor, Professor Vincent Puri. Guest of honor, Professor Bhim Singh, Professor Valentina, Dr. Nishad, who is Technical Chair, IEEE GUCON 2020, Professor Saad, Professor Paul, and Ravindra, who is Organizing Chair for this conference. Very good evening. It's been truly inspiration and inspiring day for me, having galaxy of all IEEE senior researchers to be part of this valedictory. So GUCON 2020 got huge response from all over the world and has so far exceeded to our expectations and indeed encouraging. It's my great pleasure to highlight the Galgotias University support for this conference and express our appreciation and gratitude to all the contributors for its success. In my personal capacity, especially to Professor Saad, Professor Nishad, and for taking up this conference to this height. And I would like to thank all our authors, reviewers, and program chairs, session track chairs for building such an emerging conference and building such an emerging, engaging conference, which has really raised the bar of the all past GUCONs and all other conferences which have been held in this region. As well as GU's long-standing partner IEEE for our continued work together to expand our highly productive relationship. Thank you to all our sponsors, co-sponsors, co-host institutes as well and organizations. I thank you to IEEE for financially sponsoring this conference. In 2020, we expect to see ever-increasing adoption of AI in various use cases such as AI at edge, cognitive robots, drones, everywhere, whether we take it on smart grid or we take it on energy, so conventional, non-conventional energy, so as well as all the verticals, including cyber security, cyber physical system, machine and machine learning, new communication technology. Everywhere there was a dominance of artificial intelligence. The AI, which is bringing us closer together, the government, industry, academia, civil society, everybody is working together to ensure that AI is associated with everything and anything, and which fulfills its potential to improve the quality of worldwide. Experts from different fields of expertise are coming together to align the incentives for innovation and solve the problems of AI. We see the connections forming amongst AI specialists, data analysts, and experts in related domain to benefit from AI applications, domains where AI could make the key contribution to sustainable development. The insight shared by IEEE GUCON International Conference on Computing, Power, and Communication Technologies will contribute to the growing strength of these connections, highlighting yet more opportunities for new partners on the global scale. We hope that you all stay committed and work for the prospects to encourage ethical research and innovation. I wish to thank an amazing lineup of keynote speakers for taking their time to share their invaluable thoughts and insights. I would also like to acknowledge the exceptional work of our team. I wish to thank amazing keynote speakers for taking out their time for thoughts and insights, and also with the words like, let me express my sincere gratitude although we could not host all of you to be in the campus, the way I have said the same words at the inauguration, I would like to say the same. I wanted to extend warm welcome to all of you to GU campus in coming days. Maybe after new normal, when the things would be normal, I would be will like to have all of you to be associated with us at research front for collaborative activities, for FDPs and research collaboration, and in person in GU campus in 2021. We hope that all our work, whatever we have done together, would be really accepted and appreciated by all the volunteers and the authors who have presented their papers. I'm sure they had very fruitful research experience in the last 3 days. Last but not the least, look forward to meet you, all of you, in person for GUCON 2021 at Greater Noida, NCR next year. Thank you. And once again, I welcome you all for this valedictory function. Good work, Ravindra. Over to Pallavi.
I would like to invite Dr. Nishad Mendes, Tech 2020, for giving the conference report.
Thank you. So, as one of the technical chairs of GUCON 2020 and Iis board member, I would like to take this opportunity to thank all organizers, authors, and reviewers, and other volunteers who helped to make this conference successful and vibrant one. We received 602 papers, and out of which only 162 papers were selected to present in this conference through a thorough peer review process. We received papers from many other countries that shows the truly global nature of this event. In addition to the 10 general tracks on the electrical, computer, and electronics engineering domain, the conference we had 2 special tracks covering key emerging engineering areas such as artificial intelligence, smart grid, and industrial automation. I consider this is timely requirement as it provides a forum for all of us to be enlightened on the future technological advances that will be taking place in this space. As one of the session chairs of this conference, I was truly fascinated by seeing the highly dynamism between the presenters and the audiences. And in my view, and I believe all of you are in the same view, that we had a very successful conference in respect of the challenges due to COVID-19. Now GUCON 2020 is over, and we have a great get ready for GUCON 2021 with new lessons learned and with the same spirit and courage and enthusiasm that we already possessed. I'm confident and hopeful that we will be able to host a truly remarkable event in 2021 as well. For this, I wish all the organizers good luck and best wishes for their endeavors towards the GUCON 2021. Thank you.
For GUCON 2021. Now, I would like to invite Dr. Chief Guest of this session, Dr. Arun K. Tripathi, Director General of National Institute of Solar Energy, for giving
Pallavi.
speech. Yes, sir.
Robert sir is there.
Okay. Our guest today, our guest of honor is Professor Robert J. Howlett from KES International Research University. And now I would like him to come and give his speech.
You unmute yourself.
Can you hear me now?
Yes.
Sorry about that. I was going to show a couple of slides, but I don't seem to be able to share my screen. Hi, yes, I can. There we go. Sorry about this, ladies and gentlemen. Please excuse me. There we go. So thank you very much for the invitation to attend. I was going to say come to this conference, but of course I'm not coming to it, but I'm attending it. It looks like it's been a very interesting couple of days for those of you that were able to be at the conference. My name is Bob Howlett. I'm the academic chair of the CARES International organisation, and I'm also fortunate enough to be a visiting professor at prominent university in Romania, Oral Vlachou University, and at Bournemouth University in the UK. What I'd like to say to you in not very much time is a few things relating to COVID-19 and the challenge, and how maybe we can see this as something that obviously has been a disaster and has caused a tremendous amount of distress, but might also be kind of a catalyst to a cleaner and a more resilient world. So just a few words about the organisation I represent, CARES International. It's a professional body for researchers, mainly in universities, working on research in artificial intelligence, sustainable energy, sustainable buildings, sustainable design and manufacture. And we've also done some work in knowledge transfer and innovation. So we have our own portfolio of conferences. We have a journal on intelligent systems, and we have two book series in conjunction with Springer, Smart Innovation Systems and Technologies, and Advances in Sustainability Science and Technology. And we are always pleased to receive high quality proposals for volumes in one of those two series, conference proceedings, research monographs, research texts, or whatever. Always proposals, always welcome. So COVID-19, one might say, who could imagine that we would be here? But actually, it's not so unforeseen. COVID-19, you've probably heard at various times during the conference, has caused an expectation that global energy demand will fall by about 6% by the end of the year. Global CO2 will fall by about 8% by the end of the year. And those are good things. But of course, accompanying that, there is a worldwide death toll of about 1 million, economic decline and contraction of economies, which itself will cause not just distress, but death as well. Governments are, of course, injecting stimulus funding to, with the aim of restarting economic growth and getting economies going again. The International Renewable Energy Agency recently published a set of pathways which suggested that based on renewables and energy efficiency measures, we could, over years, limit global temperature rises to 2 degrees, certainly, hopefully to within 1.5 degrees. And interestingly, what they showed was that the transformation would be self-funding. It's often thought that renewable energy is costing money, although reducing carbon. But what they've shown is that in this case, the transformation will be self-funding, and for each dollar spent, you'd get a return of something like $3 to $8 a profit, you might say. So the whole thing would be self-funding. So we've got the opportunity to bounce back cleaner. But more than that, oops, there we are. We should say that disasters are not completely unexpected. They do happen regularly. We've had pandemics throughout history: 1918 flu, 1889 flu, SARS, MERS, the Black Death. We've had natural disasters across the world, the 2014 tsunami, the 2010 earthquake in Haiti, and the tsunami in 2011, which overwhelmed the Fukushima power plant in Japan. And of course, we've got the continuing disaster caused by climate change. We've got food and water shortages across the world, displacement of population due to rising sea levels. So the question is, how can we not just bounce back cleaner, but how can we bounce back more resilient and more resistant to these kinds of disasters? So clean energy is one kind of example, one way in which we could take some of this stimulus funding and spend it in a way which makes us both cleaner and more resilient. Now, the energy landscape is influenced by a whole set of overlapping technologies. Photovoltaics, as you will know, are getting very much cheaper. Battery storage has declined in cost enormously. We've got high power computing, network sensors via the Internet of Things, going to provide information for analysis by artificial intelligence and machine learning to accomplish better control of energy systems, prediction of anticipated energy demand and availability. And because energy is used very much for heating, space heating in homes, offices, and so on across the world, we have to take heat into account. And the decarbonisation of the heat chain means increasing attention being paid to heat pumps. So we've got a whole set of overlapping technologies contributing to the development of energy. We've also got the restructuring of energy from a mainly centralised system to a more distributed approach, where microgrids, decomposed sections of the energy infrastructure are increasingly important and form part of the energy distribution infrastructure. So with something like a microgrid, we've got a number of advantages. We've got energy generated close to the user, so reducing transmission losses. We've got all kinds of energy sources combined together. And then we've got intelligent control, the Internet of Things, providing information via sensors and artificial intelligence doing analysis. Increasingly, as I was saying before, we have to include either heating or cooling in the equation, depending on where we are in the world. And in Europe, that's very much becoming it's very much becoming the case that we incorporate low temperature heat networks, heat pumps, and so on, and optimize just not the electrical side of the network, but also the heat side of the network as well. Where does resiliency come in? Well, if our system has a grid connection, but also has the ability to island from the network, then if there is a grid outage, a failure of the grid, then the microgrid becomes able to function by itself and gives you that measure of independence and resilience. There were suggestions in some parts of the world that COVID would cause staff at power plants to become unable to operate the plant. I don't think it ever happened because measures were put in place to obviate that. But you know, that was a possibility. And if you have a decomposed structure, a microgrid, then that gives you a greater measure of resilience. As an earlier speaker said, I think artificial intelligence in energy systems is becoming increasingly important. And really just I'm giving you a summary, though there are some areas in which artificial intelligence can be important in energy systems. So, conclusions. We should be looking at the recovery after COVID-19 to boost the transition to low carbon energy, but also ensure the resilience and security of supply of energy. We should be looking not just at electrical power, but heating and cooling in combination with electrical power, and looking at optimizing both of those things together. And we have the fusion of technologies, renewables, storage, heat pumps, artificial intelligence, Internet of Things, and high power computing, all going together to contribute to this. But going further, what else can we do to improve our resilience and our ability to resist disasters? And I'm talking about not just sporadic disasters that kind of come and go, but also the continuing disaster, which is climate change, change in sea levels, displacement of populations, and so on. We should be thinking about maybe smarter and more resilient cities, but also maybe smarter and more resilient rural communities. Increasingly with COVID-19, we've seen home working. How can we ensure that if a disaster happens and people are forced to work at home, life goes on, but also the economy goes on? Because if the economy doesn't work, that itself will cause disaster. Thank you very much for your attention.
Thank you so much, Robert, sir. Robert. And next we have Professor Saad Mckelev. He's the guest of honor. He's our guest of honor. So he'll be giving us the conference highlights. He's the professor of electrical engineering in the University of Malaya and has been the technical chair of the IEEE GUCON-2020.
Thank you very much. Good evening, everyone. Good morning and good afternoon. So it's a pleasure. It's a pleasure to see you all. I'd like to take this opportunity to thank all the authors, the keynote speakers, the session chairs, and also the volunteers, the one working in the background. They have put a lot of efforts. I would like to have a special thank to Dr. Rabindra, who actually worked tirelessly from the announcement of the call of paper for this conference till today. For the last 3 days, we have seen very high quality papers presented, very good discussions and questions during the sessions. It happened I have chaired one of the sessions and it was very interesting. And the authors, the participants asked a number of questions. And I can see actually the quality of the papers has been significantly improved compared to GUCON 2019. And we hope for the 2021, the quality of the papers will be much higher. As I mentioned in the opening of this conference, the acceptance rate was 26%, which is very good. And we received more than 600 papers from over 20 countries. And this shows that the conference is well received by international researchers across the globe. It is unfortunate that this year we couldn't meet in person and have discussions. I hope by next year we'll be able to meet and we'll be able to continue this journey. So I would like also to thank the management of the university, led by the CEO and also the Vice Chancellor for their support for this conference. And this is, I think, the trend where we are going to hit on from now onward. We have learned many things through virtual conferences. The future will be maybe most likely will be hybrid conferences anymore. There will be no more 100% physical conferences. And I think there are many things which we can overcome, okay? Because many people actually, they have a limited fund for travels. Some of them, maybe some students have problems of travel because of visa restrictions, some due to many reasons. But through this virtual actually gives a chance and gives an avenue to everyone to participate and be part of the conference. So once again, thank you very much. I hope to see all the authors again in 2021, and wish you all the best. And take care. Stay safe and stay at home. Thank you.
Thank you, Professor Saadaw. Thank you so much. Next, we have Professor Wei Jin Lee, FIEEE. He is the professor and director of Energy Systems Research Center in the University of Texas, Arlington.
Can I share my screen?
Yes, sir.
Well, I should say good day, everybody, and it's congratulations for a successful conference. And yeah, I look at the program that the theme of the conference is very in line with the Industry Application Society, and actually it's a forefront of what we are trying to do in the Industry Application Society. And as a president-elect of the IAS, we are very happy to sponsor the conference. And so today I would like to give you some introduction about the future, or what we are looking forward to on the future development, sustainable development on the Industry Application Society. We try to be the leader on the bridging and the leading the emerging technologies. As you know, if you look at the IAS is the 5th largest society within IEEE. And our vision and the mission statement emphasize the theory and the practice. So we don't just talk about theory. We basically, okay, we emphasize on the so-called the rubber hit the road. Okay, so try to combine the theory and the practice into the society to improve the humanity for the benefit of the humanity, and to provide the safe, sustainable, reliable, and smarter electrical system. So again, we value the theory and the practice. We promote the safe, reliable, sustainable, and economical installation. We share of knowledge in our domain, just like this conference. And we create the creation of engineering standards and the recommended practice. I know for this conference, we are more emphasized on the paper presentation. However, in the future, I really encourage that we include the standard development, because this is the area that we really can bring the mature technology, mature engineer, and the young professional together and make this world a better place to live. And we also encourage the professional development of our global membership. And as you know, IAS, I could not attend the open ceremony of this conference because I have to attend IEEE Fellow Committee meeting and for the last 2 days. And it was a very busy and a fruitful event. And yes, we are glad to know that several of our IAS members are elevated to the IEEE Fellow position next year. So if you look at IIS, and IIS has a little bit different structure from other societies. Between the society and the committee, we form 4 departments. It's the process industry, industrial power conversion system, industrial commercial power system, and the manufacture system and the development. So the different department has the basically different format of operation. If you look at the color, some of them has their own conference, annual conference. Some of them join together, okay, and some of them join the ECCE, and some of them attend the IAS annual meeting. So for the sustainable development of IAS, we are looking for modernization and enhancement of the current technologies. IAS is a 55 years old society, and if you look at the department organization or the department within IAS, you have seen a lot of traditional industry. However, we are going to blend the traditional industry and then modernize it and enhance it to improve the efficiency, to improve the safety of the operation. So we try to, if you look at it, okay, and as I have mentioned earlier, this conference is in the forefront of what IAS is doing or plan to do. We are bridging and leading the emerging technologies. We talk about the smart grid. We talk about the smart cities. Actually, at the beginning of well, today is Sunday, so last week, we joined the sponsor International Smart City Conference. And again, that one is a virtual meeting, and hopefully we can meet in person next year. We also emphasize on the smart manufacturing. We also talk about the net zero building or even net positive buildings. And we emphasize on the renewable energy, how to integrate the renewable energy and distributed energy resources, energy storage systems. And we promote the data center safety, operation safety, and the reliable operation of the data center, and then also emphasize on the Industry 4.0 and the application of the 5G technology or even 6G technology into the industry application. We talk about the robot, UAV, unmanned vehicle technologies, and also the artificial intelligence, and also the AIoT, IIoT, deep learning, and machine learning. And so on the application side, we emphasize on the application of the wide bandgap semiconductors or the high frequency semiconductors, and also try to make the system more secure. We looking forward to applying the cybersecurity and the physical securities. So with that, then I really encourage everybody to join the IAS because your research really in line with the vision and the sustainable development of the future of the IAS. Thank you very much. And so looking forward to the 2021 in-person meeting. Hopefully we can meet together. And of course, as the previous speaker mentioned, this is it in the future. Okay, it will be a new normal, probably with a hybrid format. However, that in person is very important component because with that, is conclude my presentation. Again, congratulations for a successful conference, and everybody stay safe. So looking forward to see you next year. Thank you.
Thank you, Professor Vision Lee. Next, I would like to call upon our guest of honor, Professor Vincenzo Puri, FIEEE, the professor of University of Milan, Italy.
Ladies and gentlemen, namaste, good evening.
It is really a great pleasure and an honor for me to address you this evening at the valedictory ceremony of GUCON 2020. I trust that all of you are doing fine and are in good spirit. I would like to thank the Honorable Chancellor, the Chief Patrons and the Patrons, the Honorary Chairs and the Technical Chairs, and the Conference Chair, Professor Rabindranath Shaw, for the excellent organization of this conference. I would like also to thank the Galgoto University for hosting this conference, the sponsors, and all organizers for their effort to make this event a reality. Thank you also to all authors and attendees, even if the conference has been online only, since they have lighted together the lamp of knowledge and shared their ideas and achievements for the benefit of the entire scientific and professional community. This conference has been highly valuable for all of us. This conference has been a unique opportunity for sharing knowledge and advanced ideas on all aspects of computing, communication, power, and many related applications, including both technologies, theory, design methodologies, operation, and application. These topics have a continuously increasing relevance in many modern application scenarios, and they have a significant impact on our daily life. They are becoming pervasive around us, both in industry, commerce, the economy in general, transportation, healthcare, and many other sectors, as well as in the daily life of each and every one of us in our home and around in the cities. It is essential to remain on the leading edge of technology and innovation in these areas in order to ensure continuous advancement of research and applications for industry development and for stimulating entrepreneurship. Education, continuing education, social implication, and economic impact have a critical role in their widespreading understanding and social acceptance. This has been a unique opportunity within this conference to give a bright future to young professionals and the future generation. This conference has been also an extraordinary opportunity for networking, even though we had to do it only by telecommunication media. It has been a unique opportunity for creating opportunities for future research and applications to promote scientific, economic, and social development. This conference has been an opportunity for sharing our knowledge for the benefit of the humanity. Let's continue to keep the lamp of knowledge burning and bright for advancing technology for the benefit of the humanity around the world. Thank you for what you have done, for what we are doing and will do. Really, thank you. And looking forward to seeing you all in physical presence at the next edition. Thank you. Stay healthy. Namaste. Ciao.
Thank you, Vincenzo Piri, sir. Next, I would really like to call upon Professor Bhim Singh, FIEEE, who's a professor in IIT Delhi, New Delhi, India.
Well, good evening. Of course, good day to all of you. I mean, like, it's my pleasure to invite all of you here, and I really thank you all for sponsoring this conference in this subcontinent in India. And it's our pleasure that here we have a president of Industry Application Society, Professor Lee. So we welcome Professor Puri, Vincent Puri, Professor Robert, who is a chief guest, and of course Professor Saad, Professor Nisad, Professor I mean, like a Bajaj and or other linguistic, Professor Pal, who has been in the inauguration also. So it's our pleasure to, I mean, to have in this conference with us. And it has been a very nice conference. It's another way of looking the conference that during this tough time of COVID. But I have a feedback from some of authors that they've really enjoyed the conference very well. And I like to congratulate to the organizer as well as the technical chairs who did really very tough task and hosted this conference. I mean, and I personally really thanks all of you. I mean, like to be part of this conference, and wish all the best for the next GUCON in 2021. Thank you very much. Like, I mean, and my pleasure. Like, I mean. Okay.
Thank you, Professor Bhim Singh. Next, I would like to call upon Paul M. Cunningham, IEEE Division 6 Director-elect.
Thank you very much. I very much enjoyed my participation, and thank you for inviting me. The conference I felt was very well organized. Everything went very smoothly, and I look forward to contributing in future years. Thank you very much.
I would like to call upon our guest of honor, Professor Valentina E. Ballas, Professor of App Automation and Applied Informatics, Oral, Laico, University of Arad, Romania.
A very good evening, all of you. Ladies and gentlemen, dear colleagues, dear friends. It's a great honor for me to attend your conference along these 2 days, and also to be with you in the last day, the closing ceremony. I have visited India many times before, and I have many friends there. So I am so happy to see you all here, friends, collaborators on my monitor from Romania. So first of all, I saw after some good years, Preeti Bajaj, who invited me in the other university in Nagpur, and we had a very successful IEEE conference there too. Then I'm very happy to see Bob Howlett, who is visiting professor of my university, and he collaborated with us last year in a very nice conference organized with China. Then last but not least, it's Vincenzo Piuri, our dear friend that is always with us in IEEE conferences, give many good advices for all of us. And we hope this year he will be successful, because we all are with him. We support him, we vote with him. I saw what is happening here in your conference, GUCON-2020, who put a tremendous effort of papers submitted to have a control of quality and to present here in the conference. And I want to congratulate all the authors and also the organizing team, the reviewers and the volunteers too. I'm sure you will continue this successful conference in the future, and also I hope you all had a great couple of days to exchange scientific and technical information. I want to congratulate my young collaborators, because I collaborate with two young researchers here in 2 papers over the conference. It's part Beer with the review on medical image analysis with convolutional neural network, and Sampurna Mandal, together with Rambindra Nath Rao and Ankush Ghosh, with another nice paper, prediction analysis, and so on. I'm sure they will continue their successful careers with some PhD in big universities in other countries. I will support them, and again, I want to congratulate them for the papers. I would like also to congratulate everyone involved in this very successful conference, GUCON 2020. And finally, I would like to personally thank Rambindra for his dedicated and passionate service to GUCON over recent years. I appreciate very much he organized these nice conferences, and in the last 2 years, I was there with you. This year, I was virtually, but I hope next year to meet you all. I congratulate again on very interesting and well-organized conference, all people involved. Thank you.
Would now like to call upon Professor Saad Mckelev to announce the best papers of GUCON 2020.
Can you allow me to share the screen?
Sir, you are a presenter now.
Yeah, thank you. Okay, so again, the most difficult task is to select the best papers. So it was not an easy job. So I would like also to thank the session chairs actually, who did the evaluations of the papers presented. So the selection of the papers is based on 3 criteria. One is the technical contents of the paper itself and the contribution made. Second, the video presentations that is prepared, and the third is the answers to the questions during the presentation. So we think that is the most comprehensive way on how we can select the best papers. And out of 162 papers accepted and presented, we selected 10 papers. So I would like to present them one by one. The first one, as you can see here, is to Mr. or Miss Santanam Kasturi from Indian State University. The title of the paper is Post-Implementation Evaluations of Coverage in Software Testing Using Monitoring Tools. So congratulations. The next best paper, the authors or the presenter actually, we didn't put all the authors. So Rohit Kumar from IIT Delhi for his paper with the title an 18 pulse converter and 4-level cascade inverter based induction motor drive. And it was presented in SD6. I was the chair for this session anyway. All right. The next paper, best paper, is to Mr. Rohil, all right, with the title Sensor Placements of Leak Localizations in Water Distribution Networks Using Machine Learning. And it was presented in session FD2. So congratulations. The next paper is to Miss or Mr. Abhishek Ranjan from also IIT Delhi with the title Order Filter Based Solar Grid Interface Systems to Improve Power Quality Issues under Grid Voltage Distribution. And the SD was presented in SD9. Congratulations. The next best paper goes to Mr. Muhammad Nazim from Jamia Millia Islamia with the title Generating Data Sets for Software Requirements Prioritization Research, and it was presented in session FD3. Congratulations. The next best paper goes to Sandhya from IIT Roorkee with the title Performance Evaluations of Membership Functions on Fuzzy Logic Model for Solar PV Array. And it was presented in session TD6. Congratulations. The next paper, or the next best paper, is to Mirnal from IIT Hyderabad with the title An Experimental Analysis of Various Multi-Channel LiDAR Systems, and it was presented in session SD1. Congratulations. The next paper goes to Robel Sengupta from IIT Roorkee also with the title A New Reduced Switch Diode Clamp Multi-Inverter Topology, and it was presented in session TD7. The next paper goes to Mr. Ajay Kumar from IIT Hyderabad with the title Detection and Counting Teslas for Maize Crop Monitoring Using Multispectral Images, and it was presented in session SD2. Congratulations. Last but not least, the last best paper was to Mr. Marif Siddiq from University of Malaya with the title Switch Capacitor Based 7-Level Triple Voltage Gain Boost Inverter 7L TVG-BI, and it was presented in session TD10. So once again, congratulations to all the authors and also co-authors, and special thanks to the session chairs for the evaluations performed. And as I say, our evaluations is based on the 3 criteria, which is the technical contributions in the paper, second is the video, and the third is the answers to the questions during the presentation. Thank you.
Thank you, Professor Saad, and a hearty congratulations to all authors and co-authors that won the best papers. And now we have a vote of now we have a vote of thanks by Professor Saravanan D, Belgodias University, India.
A very good evening to all. On behalf of GUCON 2020, a third IEEE International Conference of Power, Computing, Communication and Technologies, I feel glad to express my gratitude on this day. I feel very proud to thank our Honorable Shri Sunil Galgutia, Chancellor, Galgutias University, and Honorable Shri Dhruv Galgutia, CEO, Galgutias University, for their constant support and encouragement towards the conference. Sir has supported in all carry out this event every year. Thank you so much, sir. I thank our most respected Professor Dr. Preeti Bajaj, Vice Chancellor, Galgutias University, who is the backbone of this conference. Ma'am guided and continuously monitored us to make this event as a grand success. Thank you, ma'am. It's my immense pleasure to thank our today's chief guest, Professor Robert J. Howell, KES International Research University of Sister Business Incubation Center, Bergnur Regis, for his immediate acceptance of our invitation and join us with your busiest schedule. Your valuable address, which direct our researchers to work on the need of heart to satisfy the energy demand by using intelligent technologies to that helps the earth to breathe. Thank you, sir. I thank our technical chair, IEEE GUCON-2020, Dr. Nishad Mendes, DNV, GL Australia, and Professor Sir Mckelev, Professor of Electrical Engineering, University of Malay, for their constant support throughout journey of GUCON-2020. Thank you, sir. I extend my hearty thanks to our guest, Professor V. Jenli, Fellow IEEE, Professor and Director, Energy Systems Research Center, University of Texas, for your valuable address on key role of IEEE Iis towards the sustainable development. Thank you, sir. I thank our guest, Professor Vincenzo Puri, Fellow IEEE, Professor, University of Milan, Italy. Sir, associated with us since GUCON 2018, we need your support in the future too, sir. Thank you, sir. I extend my hearty thanks to our guest, Professor Dr. V. John Matthews, Fellow IEEE, School of Electrical Engineering and Computer Science, University, USA, for your valuable address. Thank you, sir. I thank our guest, Professor Beam Singh, Fellow IEEE, Professor, Indian Institute of Technology, New Delhi, for your support. Thank you, sir. I thank our guest, Professor Paul M. Cunningham, Executive Director, IST Africa, Institute of IEEE Division 6, Direct. Our beloved guest, Professor Valentina E. Ballas, Professor of Automation and Applied Informatics, Oral Lasa, University of Arad, Romania. Thank you, ma'am, for your enormous support towards us. I thank all our keynote speakers for all their remarkable address, which will ignite our researchers to work on the advanced technologies. I should thank all our session chairs for their valuable time, which they have spent to suggest the authors for the next level of work. I extend my hearty thanks to organizing committee members, IEEE IAS GUCON license, Professor Dalip Mohala, IEEE IAS board member, publicity chair, Professor Prashant R. Nair, Amirta Vishwavidyadeepam, India, conference joint secretary, Mr. Himanshu Karan, who deliberately worked for this conference since 2020 was announced. Thank you, Himanshu, and the organizing members, Professor Sanjay Das, Professor Ankush Ghosh, Professor Rohit Tripathi, and Professor Lokesh Garg, who spent their time for the last 3 days to make this event as a grand success. Thank you all. The student members, Vishesh Kumar Mishra, Sampurna Mandal, Titash Chaudhary, Trisha Sinha, Shikha Chandra, Arshvi Das, Mohammad Bashrat Moons, Rupali Srivastav, Pratul Kumar Singh, Devesha Satya, Aryan, Pallavi, Vijita, Kodal, and Artwell, for their work which they have extended day and night to make this event a grand success for the last 3 days. Thank you all. I should thank all our TPC members for their constant support they have made to scrutinize the paper to fulfill the objective of this conference. Thank you all the members which they were not able to join. Still, we thank all the TPC members. We need their support in future too. I should thank our sponsors for their constant support towards GUCON 2020. The GUCON was branded and success because of our conference chair, Professor Rabindranath Shah, who dedicatedly working every day to make this event as a grand success. Because of him, we are here to celebrate this conference. I thank Professor Rabindranath Shah for his hard work to make this event as a grand success. Thank you all.
Now we have Professor Wei Jen Lee to announce the dates of the GUCON 2021.
We cannot hear you. We cannot hear you.
Well, now you can you now? Okay, thank you very much for inviting me to attend this closing ceremony, and congratulations for the successful 2020 GUCON, and looking forward to seeing you in the 2021 event. Hopefully we can meet in person, and then we can do the in-person networking and enjoying the hospitality in India. And thank you very much, and everybody stay safe. Okay, don't just stay at home, because we need some activity, some exercise, okay, to keep your physical and the mental health. And again, congratulations for a successful conference.
Thank you, sir. This is Sir Ravinder here, and we will organize GUCON 21 under your leadership, sir. You become president of IES.
Well, thank you.
Thank you all.
Everyone, and big clap for Ravinder sir.
Thank you.
Thank you.